Page 224, please. You can turn your books. Page 224. I'm going to record our lesson. I think I recorded first hour's Zoom, and I don't think I had the mic on. So I think it's a lesson with no talking. So that probably isn't very good. So I'm going to record ours, which won't be any different than normal, really. Just that I'm going to record this. So today we're going to talk about classifying triangles. And today's lesson is pretty self-explanatory. We're going to classify them. One, we're going to classify them based on angle measure. Two, we're going to classify them based on side lengths. So your objectives today, I can classify triangles by their angle measures and side lengths, and I can use triangle classification to find angle measures and side lengths. So we're going to tell you what a triangle is. You're going to be able to use some stuff that you know about that triangle to find angle measures and side lengths, and then you're also going to be able to classify them. You're going to be given a picture or whatever angle measures, and you're going to be able to classify them. I would say today's lesson is, in my opinion, pretty easy, especially compared to the last two. We're going to talk about acute, equiangular, right, obtuse triangles. That's all angle measure right there, those top four. That's all how we classify on certain angle measures. And the bottom three, equilateral, isosceles, and scalene, are all based on side lengths. So whatever their side lengths are is what we would classify them there. Triangles, a polygon with three sides. Triangles can be classified two ways: angle measures, side lengths. This is triangle ABC. AB, BC, and AC are all sides of triangle ABC. ABC are the triangle's vertices, so that's where the two sides meet. Classification by angle measures. Acute triangles have three acute angles. So three angles less than 90 degrees. Equiangular triangles have three congruent angles, congruent acute angles. So again, angle measures here. These little arcs mean that all three of those angles are congruent. That means it's equiangular. A right triangle has one right angle, and then the other two angles are acute. And an obtuse triangle has one obtuse angle, and then the other two are acute. That's an obtuse triangle. Any questions on those? We've dealt with those for a long time, right? Okay. Now we're going to use, we're going to use what we know about these triangles to classify them. So the first triangle we're going to look at is BDC. So BDC. It's this goofy looking one here. This one's 10 degrees, this angle. This angle is less than 90, correct? Right? This angle's 90. So if we're talking about BD, that angle, BDC, that's less than 90. So we have two acutes. And then that one is 100 degrees. So 100 degrees would be obtuse. So we have one obtuse, two acutes. That would be an obtuse triangle. Okay? Triangle BDC is obtuse. Make sense? Find the angle measures. Then you can decide whether it is obtuse, equiangular, acute, or right. Next one, ABD. So we have this little dinky sliver right here, ABD. This angle here, D, is 20 degrees. This angle right here, angle A, is 80 degrees. So to find this angle, and I know, okay, let's talk about this first before we get into this. We have not developed the triangle sum theorem yet. Okay, and what the triangle sum theorem tells us is the three angles in a triangle add up to 180. We have not developed that yet. So we cannot use that to say that the next angle is blank because it should add up to 180. We can't say that yet. So we have to use math and stuff like that. So ABC, this line here is a line, right? It's linear. So that means this angle and this angle should add up to 180, right? Because it's a linear pair. So if this is 100, how big is this angle? How big is this angle right here? If this angle is 100, how big is this angle? Remember, it's 180, so it'd be 100 or 180 minus 100, which means this angle would be 80. So this angle's 80, this angle's 80, and this angle's 20. So we have an 80, 80, 20. They're all acute, so that would be an acute triangle. So these two have to be supplementary because they're a linear pair. This is 100, this has to be 80, this is 80, this is 20. So ABD is an acute triangle by definition. Do this one. Find or classify, triangle FHG by its angle measures. Now, remember, you don't know that a triangle adds up to 180 yet. Okay, you can't use that because we haven't developed that yet. We'll do that later today, but we haven't done that yet. So you have to do some other sort of math to get yourself to understand what that other angle measure is. Okay? Classify that triangle. All right, Reese, how big is that angle?
So 90 degrees.
The whole angle is 90, right?
60.
Okay, so it's 60. So how'd you find 60?
I said it equal to 180.
Remember, we don't know that yet. Okay, so if this is 90, right? You just said that whole angle is 90, right? And this angle is 30, how big is this angle? Right, so 90 minus 30, right? Make sense? So this one we can find because 90 minus 30 is 60. And then of course we have 60, 60, 60. So that makes it an equiangular, triangle, right? Equiangular. I get it. We know that a triangle adds up to 180, but we have not done that yet. We have not proved that yet. So we can't use that. It's technically a proof. We can't use that proof yet, okay? Just so you guys are aware. We can't really do that yet. We're going to prove it today at the end of the hour or towards when we get done with this stuff. We're going to prove it. But right now, we cannot prove that, okay? So it's equiangular, right? All right. We're going to classify by side lengths. First one is equilateral. If all three sides are congruent, then it is equilateral. Next one is isosceles. If at least, now listen, the definition is at least two sides are congruent. So actually an equilateral is also isosceles, isn't it? Because doesn't it have at least two sides that are congruent? Right? So an isosceles triangle has two sides congruent. The third is probably not. Usually it's not. Could it be? Yeah, it could be. But we don't need to know that right now. We just need to know two of them. And the last one is called scalene, and that's none of the sides are congruent. There's no congruent sides. They're all different. That's scalene. Okay? When you look at a figure, you cannot assume stuff. Okay? You can't just say, well, it looks like a right angle, so I'm going to call it a right angle. We can't do that in geometry. It has to be either proven or you have to be able to prove it. Okay? That's kind of why when I talked to Reese there, it's like, I know you guys know that, but we can't use that until we prove it, okay? All right, we're gonna classify these by side lengths. So we wanna do EHF, EHF. We see that EF and FH are congruent. Therefore, they're both 10, because EF is 10, so 12 is different, that's different. So it's 10, 10, 12, so that would be an isosceles triangle. Two of the sides are congruent. EHG, so EHG, we see this one's 12, this one's 11, and this one would actually add up to be 14. So they're all three different, so that would be scalene. So that triangle is scalene. You do, check it out, number 2. On the bottom of page, or the middle of page 225. Classify ACD by its side lengths. All right, let's take a look at this one. ACD, ACD, that's this triangle here, this little sliver over here. AC is 15 because it's the same as this one. AD is 18 and CD is 5. So because those are all different, this would be called a scalene triangle. Questions on that one? Just find the length of them. Make sure you find the lengths and understand that. Yeah. All right, now we're going to use triangle classification. So now you're going to be given some information about a triangle, and then you're going to use what you know about those classifications to solve some numbers or some side lengths or some angles. In this case, we have 3 side lengths. We have JK, KL, and JL, and we have this triangle. And what kind of triangle is this? Isosceles, right. So we know that 2 sides are congruent. JK and KL are congruent. If I know those are congruent, then I know that they're equal. If they're congruent, they're equal. Then we can substitute this and this in for these 2 because we got substitution property. Then we can solve for X and get X, okay? Because that's step 1. We really want to find the value of X, okay? We want to know the side lengths, but we have to find X first. We can't find the side lengths without X. So we subtract 2X from both sides and add 10.7 to both sides. And we get 2X equals 17, divide by 2, and we get X is 8.5. So now I know what X is. That's not my answer though. I have to find the side lengths. So I'm going to substitute 8.5 into all of these, and I should find JK and KL to be the same. If JK and KL are different, then you did something wrong. Your X value is not correct. In this case, we got 23 and 23, so that's good. That checks out. That means my answer should be right. And then JL is 44.5. And again, I don't care what this picture looks like. I know that JL looks longer than JK and KL, as well as it should be, okay? But the picture might not look totally like what you get. So you just don't worry about what the picture looks like. You do the math, you come up with what they tell you, you use what they tell you, and your answers should be right. Questions on that one? Using what you know about angles and side lengths. All right, do the check it out here. Find the side lengths of equilateral FGH, equilateral triangle FGH. All right, first things first, we know that all of these are congruent, FG, GH, and FH, because it's an equilateral triangle. So we know all of those should be congruent technically, right? Okay. If they're all congruent, then they're all equal. And if they're all equal, then I can set two of them equal to each other and solve for y. Doesn't matter what two you used, any two will work because they're all congruent. So they set FG equal to GH, and then they set these two equal to each other. So they substituted FG and GH in and then solved this for y. So they subtracted 2y from both sides and added 4 to both sides, and they get y is 7. Any two that you do, you should have got y equals 7. Okay, everybody get that? Okay, then you need to substitute this back into each one of these. And in reality, you should only have to substitute it into one and then go from there. But we want to probably make sure that our answers all come out to be the same, because if they don't, then we probably did something wrong getting y. So let's substitute it into everyone. We get 17, 17, and 17. So there we go. Those worked out. Okay. So again, we know it's like that because of the equilateral triangle. A steel mill produces roof supports by welding pieces of steel beams into equilateral triangles. Each side of the triangle is 18 feet long. How many triangles can be formed from 420 feet of steel beam? Well, we know one side of the triangle is 18. The other two sides are also 18 because it's equilateral. So it's 18 times 3 to find the perimeter of our equilateral triangle. And then we need to take 420 divided by 54. So we take 420 divided by 54. We get 7 and 7/9 triangles. We can't make 8, but we can make 7. So in reality, they can make 7 triangles out of 420 feet of steel beam. Find the perimeter essentially, or use what you know about the triangle to find the perimeter, and then divide is essentially what you're doing. I want you guys to do, check it out, 4A and 4B. Do both of them, please. Find the amount of roof supports. How many of those roof supports you can make. All right, let's take a look at these. First one, we have an equilateral triangle with 7-inch sides. So that's 7 times 3, that's 21. We need to take 100 divided by 21. And we get 4 and 16 21sts, or just 4 triangles. They can make 4 whole triangles. And the next one is 10 times 3, which is 30, and then 100 divided by 30, which is 3 and 1/3. So the manufacturer can make 3 whole. Questions on those? Okay, we are going to develop the triangle sum theorem. So this is what we talked about, or what we talked about before. Right now, we don't know that a triangle's angles add up to 180. Okay, technically, we don't know that. Okay, you know that, but we can't prove that. Okay, so we're going to prove that right now. So here's our proof. Okay, we are given that this is a triangle, ABC. Okay, we want to prove the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. With me? Okay, now we're going to use some of our previous information to figure out some of this stuff. Okay? So what we're going to do first is we're going to draw a line that's parallel to AC, and it goes through point B. Okay, so I'm going to draw a line through point B, and it is parallel to line AC. In other words, if this line extended, which it could or should or would, it's parallel to that. Okay? And now we have created two more angles, technically. We have created angle 4 and angle 5. Okay, so that's my first step. Okay? So if we're going in a 2-column proof, we'll call this line D. We're going to draw line D parallel to segment AC, or side AC. Through B, sorry. Through point B, we need to put that. How can we do that? That's just construction. Okay, the parallel postulate tells us that, and parallel postulate, we can just construct that. Parallel postulate. Two lines are parallel. In other words, we kind of did that ourselves. Now we need to prove some stuff from there. What can I prove? What's the first thing I can prove now? Oh, there's two things I can prove, but what's one of the two things I can prove? And we have a bunch of theorems about parallel lines cut by transversals. We don't have any of those yet. We have a slug load of them. Okay, we have 4 of them actually. So find one that works with these angles here. Remember, this line extends. This is a line we're talking about. So we know that angle 3 is congruent to angle 5 because of the alternate interior angles. Here. We also know that angle 1 is congruent to angle 4 because of the alternate interior angles. Here. So we know that those are congruent. We also know that if they're congruent, they are equal. So we can change the congruency to equals. So we can change the measure of angle 5, or the measure of angle 3, excuse me, equals the measure of angle 5. We can also change the measure of angle 1 equals the measure of angle 4. And again, definition of congruent angles. If they're congruent, guess what? They're also equal. Why did we change them to equals? For the fun of it? I just did that because I wanted to, right? Isn't my proof in equals? So why would I want to deal with congruency? Okay, so I got to change them to equals. Now what do I know about 4, 2, and 5? They are equal to 180, right? They form a line, don't they? A straight angle. So those three angles add up to 180 degrees. And that is, I don't know what the definition, addition postulate, I guess. So the angle addition postulate, because these three angles added together equals the straight angle. So it's the angle addition postulate. And it is the definition of a straight angle. Angle addition postulate. And the definition of a straight angle. A straight angle is 180 degrees. And now what can we do? Now what can we do?
Substitute.
Right. So I'm going to put in measure angle 1 for the measure angle 4 because I don't want the measure of angle 4. I want the measure of angle 1. And I'm going to leave the measure of angle 2 because I don't really have anything to substitute anyway, but that's what I'm going to leave it as. And I'm going to substitute 3 in for the angle 5. And that is substitution. And there's my proof. I've now proved it. So now we have proven that those three angles have to add up to 180 degrees. Okay? Make sense? So anytime you deal with a triangle and you need to prove some angles, you can draw another line through one of the vertices and call it parallel. I mean, you can just make it parallel, and then you have a whole bunch of stuff in here that you can make really, really nice. Okay? Helps a lot with the alternate interior angles and all that other stuff with parallel lines. Questions? Okay, your assignment is on the board, 12 to 29. Give you a lot of time. Hopefully you got 10, 15, 20 minutes here to work. That's awesome. The rest of the time is yours to work.